collaterals. Quadrilateral. I'm thinking quadrantals. I'm thinking quadratics. No, there's a lot of math going on lately. So when we're talking about the special things versus the quadrilaterals, I had to look at the word again, make sure I say it like a doofus, is that quadrilaterals just have four sides. They have four sides, four angles. And we looked at all the different shapes and things like that before in the past. We know that the sum of the interior angles of all quadrilaterals is the same. It is that again. The sum of the interior angles of all quadrilaterals is 360. No matter what, if you have four angles, the sum of the interior will always be 360. So that's one thing that's dead certain. The other thing that we did was we broke them into what we say family trees, where we had parallelograms, I gave up real quick on that one. Where we had parallelograms, we had the non-parallelograms. And we'll chart this out separately. And when we had parallelograms, we had the shapes, knowing there were four sides, but it also had a bunch of properties. So, what were some of the properties of a parallelogram? Opposite sides are parallel. Convenient because it's called a parallelogram, that there should be at least something parallel here. You know, it's weird, but yes, opposite sides are parallel. Opposite sides are congruent. Very good. First hour couldn't remember that one to save their lives. Yeah, I felt bad for them. I don't know. What else? Opposite angles are congruent. Very good. Very good, Mr. Whatever, useless.
I'm sorry, I'm really
an idiot? Or that's no. What else is there?
Diagonal.
What about diagonals? Yes, there are diagonals. What do they do? Shh, ladies. What do the diagonals of these guys do to one another? They don't, not necessarily. They bisect each other. Diagonals bisect each other. So diagonals bisect. Okay. What else? Good. Riley, put your phone away. Consecutive angles or something. No matter which angle you pick for what vertex, the next angle either to your left, to your right, to your above, or your below, it is going to be your supplement in a parallelogram. No matter what, it always works like that. Okay? So that was your first one, and that was the basics of everything, the basis of everything else. Everything else boiled out after that. Once we got out of the parallelograms, we had two others. We had the rectangle and the rhombus. Now remember, everything we already know that a rectangle is a parallelogram, so all the properties of that still hold true, but what made a rectangle a rectangle? It's what? Right angles, good. Rectangle, what makes it a rectangle more specific than a parallelogram is that you have four right angles. What else? Still a parallelogram, so we know that. There's something else that's... Do you need something to write with, Kevin? We can probably ask people. I'm sure somebody in here might be nice to help share something.
Sorry,
Be a good idea, yes. What else is there? Yes, they have 4 sides. Thank you. Thank you very much. Still a parallelogram. What's more specific about a rectangle? You got the right angles. There's one other thing that makes it more specific. What's that? Good. Diagonals are congruent. So in other words, you were being resourceful?
Yeah.
Wow, way to go.
Was they put more properties of rhombus, rectangles, and squares?
Sure. Sorry, I didn't draw that very well.
Nigel, do you have a writing intense ideas?
So we know that the way that we wrote this out, since we know that diagonals bisect one another, what we did was, instead of just marking the 2 diagonals being congruent, since they bisect each other and they are congruent, we just marked all 4 pieces to be the same value. Okay? We marked them to be the same value. It was an easier way to do it. It's either way is fine, but this is less of a mess, if you will, make it go. Okay. That's what made the rectangle the rectangle. Obviously, when you had rectangles, you had the right triangles. You had 2 different sets of isosceles triangles. You had different congruent base angles. You had base angles that were complementary to one another because they formed that right angle, and so on and so on. Then the rhombus was also a parallelogram, but it wasn't a rectangle. What made a rhombus a rhombus? Where's my tinfoil hat? What made a rhombus a rhombus?
Diagonals, bisect, the angles of one.
Good. The diagonals bisect the angles of a rhombus. That's the fancy version, because opposite angles are still congruent, but the diagonals bisect it. What else do the diagonals do in said rhombus? You're right, but what about the diagonals? Yeah, I figured since we're talking about it, we might as well just finish that part out. And then you have your, no, we had the 4 congruent sides. That's what made the rhombus different. It had the diagonals that were perpendicular, you had the 4 sides that were congruent, and then you had the angles, base angles, if you will, of the rhombus were always bisected. Excuse me. That's where that became more specific. Still has all the other same properties as everything else. Nothing else from a parallelogram changes from it. It just gets those extra parts. And then lastly, the offshoot of the both of them is the square. The good old-fashioned square had the 4 right angles, 4 congruent sides, diagonals that are perpendicular, congruent with these, and then all these 45s all the way around. Okay. We were talking in my Algebra 2 class today, we were just starting to get into our trigonometry unit. And the trigonometry unit, as we get going into it, starts to deal with what we call the unit circle. And as you use what's called the unit circle, you get specific angle measures. And we talk about them in terms of what are called radians. It's a portion of a circle's circumference, if you will. And when we do this, there's only 3 angles that we ever worry about. Those 3 angles come from the 2 sections, the 30-60-90s and the 45-45-90s. Because absolutely everything that we do in Algebra 2 via trigonometry kind of builds off of those triangles. Now, the honors class is going to be a little bit different than like the regulars or the AB class, whereas I spend 6 to 8 weeks in trigonometry, and the majority of it is without a calculator. Whereas the other classes, they'll spend about a month or so here or there with a calculator and whatnot, and you probably won't get as much as in radian measure, but that's okay. The idea that some classes spend more time in it versus others is that way all upper level math is kind of based upon that part. So as you guys get into college and things like that, you'll come back and go, oh, that's right, Murphy was right. Figure. But yeah, these never go away. Those specials are important. Questions about parallelograms? Okay. The non. We had two basic ideas of the non-parallelograms, and one of those types had a more specific one. So, one of them was the trapezoid. So the good old-fashioned trapezoid, what made that more a specific quadrilateral is that it had only one set of parallel sides. It had the one set of parallel sides. There really wasn't anything else with the boring old trapezoid. I think the only other thing that I talked about with you guys was, if you think about with parallel sides, think of the two sections that connect them. Think of those as two separate transversals. So if you do that, if you have two parallel lines cut by a transversal, these two angles were always supplementary. And then these two angles here were also supplementary to each other. That was really the only other relationship that you could find within these things. They weren't equal across from one another. They weren't equal diagonally from one another, or anything like that. The only thing that happened was plain basic stuff with two parallel lines cut by a transversal. Consecutive interior angles were supplementary. That was the long-winded version of same side inside. They're on the same side inside. They had to eliminate it. Okay. What was the more specific trapezoid? The isosceles, right. Now the isosceles trapezoid had your two parallel sides. I'm sorry. It had the one set of parallel sides, but what else did it have? What does an isosceles triangle have?
Oh, as the base.
Yeah, it's got the two congruent legs.
So that was the inverted.
Exactly. So if you think about in terms of a trapezoid, if I set the trapezoid like that, your legs are always looking at angles. Well, in this case, they can look up or look down. So if you look up, that means these two are the same. If you look down, these two are the same. And I guess you can do the same thing if you're up or down, if you're going like this with the sides, whatever. It's the angles that are next to the parallel parts are congruent to one another, if we want to think of it that way. Again, they're not congruent going across one another or any of that. But what else was there in an isosceles trapezoid that made it an isosceles trapezoid? There's one other thing. You don't see it very often. What? No, there's no bisector here. What they had were,
Oh, segment, next which one?
they had that, but that was for all of them. The diagonals in the isosceles were congruent. Okay. The mid segment is in both of them. So the mid segment is equal to half the mid segment is the sum of the bases. Or if you take the mid segment is equal to half the sum of the bases. Wrote that backwards. Or double the mid segment equals the sum of the bases. Think of that mid segment as a midpoint with only having one coordinate. And I think a lot of that was really easy yesterday. Okay. Ready? And the last one is the height. Hey, what? Sorry. Yes, sir.
That's what we were.
I give up. What movie did you watch yesterday?
Rain Man.
Gotta watch Waffle. Gotta watch Waffle. He just died. Judge Walker died like last week. Yeah, he's 97 or 98 years old.
Maybe that's why it was on demand. It wasn't on demand before then.
Yeah. Walker just died.
Wait, who's the guy on first base? Remember the riddle?
Oh, who's on first? What's on second? I don't know who's on third. Today's pitching, tomorrow's catching.
Oh my god.
Abbott and Costello. Hey, I bet.
Wait, I don't know.
Who's on first?
Oh my god. You should show that.
If we have time, I'll show you. It's an old gag from like, oh geez, what was that? Costello?
92?
The 50s or something like that. No, the real Abbott and Costello who's on first gag is really old. Yes, ma'am. So can I go to clean one down real quick? We'll do the kite. Remember I talked about, when we talked about the kite, I told you guys to treat the kite like it was just two isosceles triangles that shared the same base. It's the easiest way to do it. Oh, shut up. It's like a writing utensil.
It's like pushing out to the left.
At least I have a writing utensil. You could have asked anybody. I'm sure somebody would have helped you out.
I did ask people, but then I didn't want to like ask across the classroom and then interrupt your class.
Hey, do any of you other bozos have something to let Mr. Bozo write with?
Yeah.
Thank you. So treat the kite as two isosceles triangles put together. When you throw that diagonal between the two, treat that as the base of both of them. That base connects where the two larger angles. Yeah, well, I'm getting at these two guys those two angles wind up being congruent because that shared base creates those angles.
Wouldn't you treat that as like a third side as well?
You can do, they're not, those triangles won't be congruent to one another, but it is a shared side. But what we do then is when we draw the other diagonal in,
We put the mark.
yeah,
Okay.
because the altitude of any isosceles triangle is the perpendicular bisector of the side, so it has to bisect it and you get all of that. And then what we said yesterday, a lot of times with kites, you see special right triangles with 30, 60, 90s, you'll see SOHCAHTOA, triple show up quite often with these things because it's really fast to make it work. And then obviously, if you don't remember that, the Pythagorean theorem also holds true. So this is that section where it forces you to know what shape has what information. Not get information, but information. I kind of pause the one syllable. Which means I want to do this.
Ah!
Don't write that down. No.
You say don't write that down?
Is this proofs?
Richard says that.
Yes, this is a proof. It's a proof that you don't listen.
Dang.
I was waiting for him to say what.
Hey, Mr. Burby, you should be on Law Now.
Who?
Law Now.
Oh,
You should
yeah.
just like fry people. We're like
You know
in
that
math
joke?
terms.
It's like a rap.
That would be funny. You just
You do understand everything, and I don't understand anything you just said.
You should be on a TV show where they make fun of each other.
out. Wild and out.
It's a show. They just make fun of each other.
So does MTV play videos anymore?
No.
No, so it's not music television.
They have my videos
Just
for
reality
learning.
shows. I remember.
I mean, there's ridiculous.
So, what I'd like you guys to do, we'll do this, I want you guys to take a couple minutes, to move this over just a bit. First thing I want you to do is off to the side after the trapezoid, put another column in for the isosceles trapezoid. And I want you guys to take some time.
There's a pencil thief, I'm telling you.
What'd you say?
There's a pencil thief.
They stole my pen.
let me do the, there we go.
Oh, there's nothing there.
What I want to do is I'd like you guys to go through and make a check mark or a yes or a no or like what things have the property. So first one is a parallelogram, rectangle, rhombus, square, kite, trapezoid, isosceles, trapezoid. Which of the shapes has all sides congruent? Check off which one has that. Take 5-6 minutes to do that while I make this chart look nicer. Every once in a while, this job is actually enjoyable. I'm kidding.
It's only enjoyable when you get paid. Don't deny it.
No. Believe me, you're not going to make $1 million teaching.
Yeah, I know.
But I really, as much as you guys think I hate you all, I only kind of do. But I really, no, this I do. I'm equal opportunity about hating this. Good. But I absolutely, I love what I do. I always have, so. What shape or shapes have all sides congruent?
Square.
Square.
Rhombus and a square.
Yes, they do. Yes, they do.
Both pairs of opposite sides are congruent.
Rectangle, rhombus, square.
Square.
I got all of them except for trapezoid.
Yeah, me too.
So both
Yeah, all
pairs
of
of opposite sides are congruent.
Yes.
So you said rectangle,
Yes.
you said square,
Yes.
you said a rhombus.
Yes. I said kite.
Now kites, our opposites aren't congruent. It's the two consecutives are.
Yeah.
What?
Hockey. He said hockey puck, Mr. Murphy.
No, you didn't. Now, what shape is a square, a rhombus, and a rectangle? What are squares, rhombuses, and rectangles?
Parallelogram.
They're also parallelograms, which means that also has it. So if a parallelogram has it,
What is that?
Wait, what's a parallelogram?
Oh.
Does it mean they are?
Aren't they all put up?
No, those are synonograms.
Oh yeah, the nonogram. That's one
yeah,
of the places.
gotta watch Wapner. It's what I feel about right now.
You have to watch the movie.
Remember, parallelograms have opposite sides that are parallel. Both sets of opposite sides are congruent. Well, the parallelogram does. A rectangle is a parallelogram. A rhombus is a parallelogram. A square is a rhombus that's a rectangle that's a parallelogram. So that means all four of them are. Both pairs of opposite sides are parallel. Well, if you have both sets of sides being parallel, you have to be a parallelogram. Which means, what else is a parallelogram on this? A rectangle.
A rhombus and
A rhombus and a square. Oh my.
I got it all right.
Okay. What shape then has exactly one set of opposite sides that are parallel? Excuse me.
A
A
trapezoid.
trapezoid
And
and
an isosceles
an
trapezoid.
That's
isosceles trapezoid.
not on.
I asked you guys to throw it on there because you'll see isosceles stuff later on. So you'll see it on the test. I know that isosceles on there. All angles are congruent.
Nice one, trap.
I got
Which ones
rectangle
have-
and square.
Rectangle and square. Very good. Exactly. One pair of opposite angles are congruent. Only one pair of opposite angles congruent.
Is it tight or tight?
It's going to be a kite. The kite has exactly one pair of opposite angles congruent. The trapezoid has the base angles next to each other. The two sets of consecutive ones that are congruent. Diagonals are perpendicular. Who has perpendicular diagonals?
Rectangle,
The
rhombus.
rhombus,
Okay.
Yeah.
Rhombus,
Rectangle
square.
does not. The rhombus, square, and kite do. The rectangle has the congruent diagonals, but not the perpendicular ones. Who has congruent diagonals?
Rectangle, rhombus, square.
Whoa.
Table rhombus.
Rectangle, square, isosceles, trapezoid. The rhombus does not have congruent diagonals. The rhombus has perpendicular diagonals. The square has the perpendicular congruent diagonals. Okay. And who bisects diagonals?
Rectangle, rhombus, square.
Which makes them all
Parallelogram.
parallelograms. All four of those bisect what? Am I not allowed to make happy faces? Fine.
No. Oh, I thought you were deleting from like sad faces. I won't be in the bad mood.
Okay. What? I tried.
And the square takes the.
All right. So let me give you guys some stuff. What I have for you this evening into the weekend is something a little bit different. The idea here of what I want you to be able to do is I want you guys to create the family tree. Yeah, I ask a lot, I know. Oops, no, I want you guys to create the family tree. And what I mean by that is, I want you guys to go through the chart that's coming towards you. Guys, I want you guys to be able to go through the chart that's coming towards you, and guys, I know I just threw stuff at you because that's easy. And I want you to write out what makes a parallelogram specifically a parallelogram. What makes a square specifically a square, and so on and so on. It might not be a bad idea to draw a picture next to it so you can mark it and go, yeah, counting. Who needs it? Okay? I want you guys to be able to do this because the idea is when we come to our test on Tuesday is that you have to know this stuff. You have to know that if I say, hey, bozo, WXYZ is a rhombus and this is equal to this, what do you do to solve for the sides or whatnot? You have to be able to draw it and identify what parts would be equal, what parts might, or if you're talking about angles, if they're supplementary, are they congruent? Things like that. But you have to know how to set up each of the pictures, okay? Deal? You got some time to work on it. My suggestion, try to fill this in without looking at anything first, okay? Try to fill this in for, right now while you're sitting in class for the next 5-10 minutes or so, without looking at your notes. See how far you can get, and then later on, go through your notes. Because you know all the answers in your notes. But see how much you actually know off the top of your head, because that's the idea. And that'll help you know what you have to study. Okay?
I know it.
Okay? Very well.